With respect for Aboriginal cultural protocols, Western Sydney University Library acknowledges the traditional custodians of the unceded lands and waterways on which our libraries are located and pay our respects to elders past, present and emerging. The university works across many different lands, and we are currently on the lands of the Burra people of the Darug Nation. We celebrate and acknowledge living cultures of Indigenous Australians and acknowledge their important contribution to teaching, learning and research. We acknowledge that the activities currently delivered across our campuses are a continuation of teaching and learning that has occurred on these lands for tens of thousands of years. We also pay our respect to any First Nations people in the meeting. In this spirit, we welcome any guests to the meeting. Western Sydney University was placed first in the world in the 2022 and 2023 Times Higher Education Impact Rankings, the only global performance measure that assesses universities against United Nations Sustainable Development Goals. The Public Thought Leadership Series, hosted by the library, aims to celebrate and promote this #1 ranking, celebrating the work being undertaken across the university as part of its Sustainability and Resilience Decadal Strategy 2030. I'll now hand over to my colleague Luke Warren, who will introduce today's speakers.
Good afternoon and welcome to the 14th event in the Public Thought Leadership Series. Allow me to introduce our esteemed speakers for today's presentation, Rethinking Approaches to Achieving Sustainable Development Goals in an Era of Smart Computing. Professor Athula Ginige holds a Bachelor of Science with first-class honours in Mechanical Engineering from the University of Moratuwa, Sri Lanka. He completed his PhD at the University of Cambridge on a Cambridge Commonwealth Scholarship. Formerly an Associate Professor at the University of Technology, Sydney, he currently is the Head of School and Professor of Information Technology at Western Sydney University. His research interests include web engineering and remote healthcare. He serves as the Editor-in-Chief of the International Journal on Advances in ICT for Emergency Regions. Professor Ginige has published widely on topics that investigate the use of ICT to empower and support humanity, ranging from sustainable microfinance, agriculture and in developing countries, disaster response and assisting patients with diabetes. Dr. Bahman Javadi is an Associate Professor in Networking and Cloud Computing at Western Sydney University. He holds a Masters of Science and PhD degrees in Computer Engineering from the Kabir University of Technology. Prior to his current role, he was a research fellow at the University of Melbourne and INRIA Rhône-Alpes, France. He is the co-founder of the Failure Trace Archive and has served on various international program committees. Dr. Javadi has published widely on the topic of cloud computing, surveillance tracking, blockchain securities, data analytics, and artificial intelligence for autonomous vehicles. Dr. Ashini Wesumperuma is an information technology lecturer at Western Sydney University, specializing in e-design and development. Dr. Wesumperuma holds a PhD from Western Sydney University, and her work explores the intersections between business process optimization, information systems, artificial intelligence, and greenhouse gas emissions. She is keen on incorporating sustainability into teaching and aims to integrate social responsibility into her learning design wherever possible, educating work-ready graduates with social conscience. Please join me in extending a warm welcome to today's speakers.
Okay, good afternoon, everyone, and thanks for the introduction. Thanks for the opportunity. So I'm Bahman Javadi from School of Computer Data Mathematical Science. So welcome to the people in the room, and also I think we have some guests online. Hope they can hear me very well. So yeah, as you can see in the screen, the topic of today is about rethinking approach for achieving SDGs in era of the smart computing. I believe many of you know about the Sustainable Development Goal, but as you may know, it's the goals set by United Nations, and these are the goals that we want to improve in the next maybe 10 years up to 2030, which there are 17 of them. So today we're going to address few of them with some of the projects that currently undertaken on Western Sydney University. So just a couple of background before we go to the presentation. First is in the right side, as you can see, all those 17 goals of sustainable development. And what we're trying to focus is how we can address them by the smart computing. And I have a slide about the smart computing, but before that, we want to look at the level and accuracy of what we're going to address those challenges. As you can see in the slide, we're going to look at the activity level, process level, and the system level. And that's the whole systematic way of addressing basically the SDG. For the smart computing, I'm sure many of you already work with many of those technology, mobile phone, maybe many of you have, wearable technology, devices that you have. So smart computing is basically the effective or efficient method to integrate all those technology to address challenges. For example, finding the better way for the training and the teaching, improving the quality of life for the patient, shopping, gaming, and many other factors that it has an impact on our day-to-day life. So integration of all the AI technology, IoT technology, communication network, mobile network, hardware and software to basically have the impact on the day-to-day activity that we're going to do. Just to make sure that's what we're trying to do in this presentation, and of course the holistic view of the research, as mentioned in the beginning of this presentation, is all university has the commitment and obligation to provide the practice and the research in sustainable development goal. And that's why in our department and our school, we set 3 themes. That the top one, as you can see, is a computing for sustainability and equality. Means that we do have the specific research team for the researcher and the students and the staff to think and, of course, innovate the techniques and the technology to be used for the sustainability and equality. And of course, there are other 2, as you can see, the intelligent decision making and foundation and algorithm discovery. But the main one is a first one that we basically, our presentation fall under that one. So today we're going to look at a few case studies and how those smart computing technology will be addressed there. So I'll stop here. I'll back to the case study, but I would like to invite Professor Athula Ginige to talk about the background of the smart computing and the food security for first. Thank you.
Thank you, Bahman, and good afternoon, everyone here and online. Before I start, a small correction about my bio. I think it was briefly mentioned I was head of school, but I was the head of school many years ago, not now. I have finished that task and I am basically dedicating my time to do smart computing, but to help smallholder farmers. Again, a quick story, how I got into this, because I have a background in mechanical engineering. You heard PhD in robotics and computer vision. But one of my mentors, going back about 12 years, gave me an interesting challenge. He's Professor Ramesh Jain at the University of California, Irvine. He said, Athula, find a project that we can do so that on the day we die, we can look back and help the humanity and be happy about it. Not with money, with our knowledge. I looked around, went to different developing countries, and found there are major issues in agriculture. Farmers trapped in a poverty cycle, committing suicide. In Sri Lanka, it's about 4,000 farmers a year. In India, it's about 20,000 farmers a year, which can be traced back to this. And it's, I don't know what the current numbers are, they are a bit old. Then I said, look, if you are doing computing, And if we are becoming a connected society, how can we make a difference? So that is what got me to start exploring this. On that theme, on one side, we have computing, and for whatever the reason, I decided I want to work in agriculture. And I think that was a very good reason, because if you can delay getting your clothes a month, a week, or even more, buying a car, getting a house. But if you don't have food, that's something you just cannot delay. You need it now when you are hungry. And there is so many challenges, and only the challenges have become more challenging because of the climate change and growing population, and many other effects of what is known as a green agriculture revolution of residue pesticides, fertilizer. So we started looking at what can be done from smart computing angle. So if you bring computing and agriculture, we can see the possibilities at 3 different levels. First, we talk about digital agriculture. Then we can talk about digitalization of agriculture. And then we can think of digital agri-food ecosystems. So let's explore some of these. Now, the very first thing is, I'm just wondering whether there's a way to get rid of that top bar. Yeah. Because the very first thing where the smart computing come, as Bahman introduced, is we have become connected. We have become connected at multiple levels. The first thing is we are connected things. That means we have sensors. Everywhere we talk about smart houses, temperature sensors, pH sensors, fertilizer sensors, moisture sensors, and they sense and they produce large amount of data. So we have become, there are sensors which is continuously sensing and which we call autonomous sensing. But not only that, we all have this device called a smartphone. And if you really think of it, with that, we have applications like Twitter, WhatsApp. Whenever we see something, a fire, a flood, we message. That means we are sensing the world and communicating it to a community to make sense out of it. But those are autonomous. That means they have been programmed. They just send the message at the right time. These are participatory because humans can act as sensors. Now, what I see is in particular parts of the world, there is enough money to put lots of autonomous sensing. But there's another part of the world where that is too expensive, but everyone has a smartphone. And this becomes the dominant way of sensing the world. So we have got connected things. And if we are connected things, then with that, we can look at connected activities. I visited a farm in Perth a couple of years ago, 30,000 acres, only 6 people work, 3 agronomists, 3 mechanics. Everything is GPS controlled because we are all connected. The tractors go GPS, turn the soil, it comes back, the mechanics then mount the various the seed containers. It goes, drop the seeds, come back, they mount the fertilizer containers. It goes, it sends various soil conditions, mix the fertilizers accordingly, comes back. And we can increase the productivity by connecting these activities using smart computing. So that's fairly well established. Many farms are going down this path. They are monitored through drones if there are pest and disease attacks. And the productivity per person has drastically increased. But that's not all. The farm produce needs to be sold. So we have the supply chains. They need various fertilizer inputs to come in. Now today, even those are connected. We have got barcodes, crowd sensing apps, cameras, various other sensors, RFID, QR codes, all sensing that automated supply chains. And then we have things like blockchain, where it established the trust, the data cannot be changed. And we have got automated processes using smart computing. So the supply chains typically tend very nicely. Having said that, we also saw during the COVID period, there were other challenges beyond technology. And we are still experiencing some of those challenges. So those are some wonderful developments. But is that enough? Now, again, Bahman introduced our goal is to create sustainable societies. So if we really look at the numbers with all these innovations that has happened, we have huge problems. People without food in one part of the world and food being wasted in another part of the world. Malnutrition is very high. This is some data from India. Then there's a whole thing about hidden hunger. That means they have the basic protein, starch, but not the micronutrients. And increasingly, more and more people are hungry today. So the question is, we have these wonderful things we can do with smart computers, sensors, etc. But we need to go beyond that. Now we need to focus on these issues, especially if we are aiming to achieve the SDG goals by 2030. So this is where we are sort of saying we need to look at sustainable development as a holistic way. We need to bring in a systems approach. So I'll show what we can do if we bring systems approach in agriculture, and my colleagues will show that it's even more general and apply to other SDGs as well. So with this, immediate focus is SDGs 1, 2, no poverty and zero hunger, but then it flow on to health and well-being, but then there's this thinking can then be extended to any other sustainable development goals. So if we take agriculture, we need to put the farmer in the middle. Because if you really look at farmer is the person who is taking the highest risk in this area. They produce, and if there's a flood, pest attack, they lose everything. And when it becomes desperate, that's when they go and commit suicide, which is a very tragic situation. But if we start to look at the activities, processes, and start connecting, we see actually the issue is a coordination failure at multiple levels. And we have identified these levels to be at the knowledge, coordination failure at the knowledge level, coordination failure at the supply chain level, that is input side, fertilizer coming into the farmers at the right time, and also going out, the harvest, connecting to the market. And also, and the other areas, they also need the money because they need money to buy the inputs, but they only get the paid at the end. So there's a gap which normally get bridged through microfinance and other areas, and even that has got challenges. But on the other hand, if you look at all these things that needs to be coordinated, knowledge can be expressed as information. Knowledge transfer can facilitate through information. If you are going to coordinate the flows of supply chains, again, by giving right information at the right time, we can coordinate that whole process. And today, money is also information. It's not the paper currency notes anymore because it's all electronic. It's information with the right levels of security. So once we have the smart computing, we can enhance all these flows. So the question is, how do we do that? So we have been researching And at the moment, probably we have done about 10 PhDs to create this system. And if you look at that, the very first thing is empowering the farmers. And we work with research institute, agriculture universities in here, Sri Lanka, India, Africa, to get that knowledge they have, digitize, and give it to them as actionable information. In a way, they can be empowered. So when I say actionable information, a good example is the GPS. Because if you think of a printed map and trying to go places, it's not easy. And some of you all may not know it, but those who have seen it, it's not easy because you have to keep reading, you have to see where you are, what is the next road, and navigate. But people used it. But when the same information is given as vector in the GPS, when it says turn left, turn right, millions and millions started using it. And that, based on that, new business models like Uber, Airbnb all evolved because of that connectivity. So similarly, we have, through our PhD projects, we have developed ontological knowledge bases to convert the crop knowledge into actionable information delivered through mobile phones. In a way, the people can be empowered. And the actions, then we can aggregate and start generating what we call market intelligence. We can say, because we know what farmers are growing, in this area, there's this much of harvest coming, this much of water is needed, this much of inputs are needed, which then can be used for coordinating the supply chains. So from that, we can generate market intelligence. In addition to that, then there are special information needs, such as pest and disease management, which we have automated, taking the knowledge from research institute and delivering through mobile phones. Then we also find sometimes the research institute don't have the right information because what they say and what farmers practice are different. So we have got community knowledge creation process happening where farm actions are fed back to the research institutions to refine the knowledge. So the whole research institute and the field become one research platform for people to work together. And once that information comes, we have created blockchain-based markets where exchanges can happen. And now we are studying how we can bring stability through supply chain resilience, organizing supply chains which can dynamically adjust based on the various conditions. So over the 10 plus, years of research, with about, I think, 8 or 9 PhDs, some completed, some still ongoing, we have developed this technology platform. And this is how it works. And before that, I had to introduce what is Vidya, because in 2020, May, we had a challenge. I know we all had the COVID. The universities had very strict restrictions with funding, etc. But we had these mobile applications and systems running in India and Sri Lanka, people depending on it. So I talked to the university. With the help of the university, we created a startup company. It's called Vidya, and people who know the Indo-Aryan languages will recognize Vidya is science. It's very much knowledge-driven way to enhance agriculture. So we have moved the day-to-day running into Vidya, and the research happens in the university. And way it works is we work with the knowledge partners, digitize that knowledge, convert into actionable. We give it to the farmers so that they can decide what crops to grow, when to grow, how much to grow based on the information. And what they do when they select, all that gets captured, and we capture 3 critical data points: name of crop, size of land, and planting date. And with that, we can use various aggregation technologies to predict how much water a particular land area will need. We can provide it to water providers. We can aggregate and predict how much input a particular geographical area will need in terms of fertilizer. We can predict what the harvest that will come and when it will come because we have those data points. And using blockchains, we have created online markers for all these people to come into contracts. And once through the online markers, they establish contracts, the water can be released to the farmers, the inputs can be delivered, farmers can deliver the harvest to the buyers, buyers can make the payments, and the payment based on the various smart contracts that were recorded in the platform will then get distributed to the farmers, their percentages, to the input suppliers, to the water suppliers, and to the knowledge partners. So you can see by using smart computing technologies and transforming information, we can coordinate the knowledge flow, the material flow, and the money flow. So that's the theory. And all that now being implemented, running in the cloud, in data centers in Singapore and India. They are all cloud-based on Docker containers. And this is sort of a high-level diagram of various modules. Each module actually can be linked back to a PhD thesis. So each module captures a work of a PhD student into this. And there is an external gateway, and we have a series of apps deployed out there for people to connect and make use of this. So here is a case study where we worked with Maharashtra Water Resource Department, and the problem was a canal 125 kilometers long, a sizable canal, irrigating 43,000 hectares, supporting 55,000 farmers. And farmers are organized into water use association. There's 123. So there is a river flowing here, but this is the canal, and all the green dots are the various gates that can be opened and closed to control the flow of water to this land. The problem is if the water continuously flows, there's too much waste due to seepage and evaporation. Again, we are looking at sustainability. How do you optimize water in this situation? So what we have done is, again, we connected the farmers to coordinate this water flow. And this is the platform. We have customized platform, and the farmers have a mobile app. Again, working with various Indian institutions, we digitized the crop knowledge, gave it through the app for farmers to select crops to grow. And based on that, the land area and the crop, we have tables to calculate water aggregation, how much water is required and when it is required. That information through dashboards is provided to the Water Resource Department, which controls the gates. Then they look at the data coming from all the farmers and decide what is the optimal schedule to open the gates, which is called water rotations. That water rotation information is given to us through spreadsheets which get loaded. And then from that, we can inform every farmer when they can expect water. So they adjust the planting dates to suit the water availability. And once they fix the planting date, we can then aggregate what is the input needs and provide that to various input suppliers. And then from that to logistics suppliers to provide that inputs at the right time. We also can predict what the harvest, when it will come. It was mainly cotton, maize in that area, and provided it into large buyers, institutional buyers, because now we are looking at an area and these people are interested in buying in bulk. rather than the brokers who buy in small quantities. So they can offer better prices. The various logistic providers can then provide the logistics at the right time to move the harvest when it is there. So you can see how the whole thing can be coordinated, and this is a project which was linked to World Bank Water Resource Group. They got us to work with all these departments. And also there were the government, water resource department coming into it. Then there was an NGO, local NGO, which went to the field, educate the farmers. We did everything through Zoom from here, and they worked on the ground. Then there was another company which was optimizing water usage, as another startup, Indian startup, which partnered and helped us to work out all the water needs. And another logistic company, Vesatago, they have a Uber type model to do the transportation used in the local vehicles. They were linked to create the material flows. So you can see through a platform like this, thinking at a system level, empowering the local community, how we can create an efficient system. It not only optimize the water use, but also increase the income, the food, minimize waste. So this is the power of systems thinking. Another quick example, which we did during the COVID time, is to look at how to sustain the food security by creating different modes of food sourcing. It's another PhD project. Many PhD projects contribute to that, because we found that food can be grown in their backyards, but then you can be more efficient if a small community get together, one person grows A, another person grows B, but in a coordinated way and share, so that they grow and share. Because the major logistic chains have broken down at that time, the supermarket model was the dominant. That is not functioning, but there were local farmers who couldn't sell, but we were able to connect them to the community as well. This we did in collaboration with the university in Sri Lanka, University of Ruhuna, and we developed and deployed an app through that, because we had the platform. So this only took us something like 60 days. Everyone worked very hard during the COVID time, where they can select crops, they get the activity calendars, they can form a community and exchange knowledge. They get various helpful information about organic, how to create fertilizers, provide feedback, weather, and also as a community, they can exchange, exchange the harvest. So these are some screenshots from that, where they can select the crops, what grows, how to grow. They can select the crops to grow. Once they select it, they get the activity calendar, which says what to do day by day, and they can grow it. They can share the outcomes with the community if they are successful, and we see a lot of messages coming up. And they also can share the surplus with the community through the harvest exchange. Then we did another project, which is ongoing, with Anand Agriculture University in India to look at ways of generating the market intelligence. So in the market, we have the farmers, traders, consumers. And how do we optimize? Because to optimize, we need to balance supply and demand. Otherwise, there's a waste or a shortage. And also, we have to minimize the cost. So we have modeled all those equations by looking at it as a system. This is a typical system. And then we looked at the things these different people try to optimize. And you can say farmers optimize the profit. Traders optimize the profit. Consumers want it at the lowest possible price. And the policymakers, the governments, wants to make sure there's enough food. supply and demand balance. You can see there are conflicting objectives. And through systems approach and modeling, we were able to find very effective solutions for this problem as well. And for that, to inform farmers about the market issues, we extended the app we developed for Sri Lanka with a new module called Market Intelligence. And in that, they will get the crop information, the past prices, the predicted prices, the various market locations, so that all that information they can use to balance the supply and demand. So once you start to think holistically, you see all these new possibilities. So to summarize, this part is we need to look at a systems approach. And the starting point is where you have a problem, you need to find a solution which is economically viable. Now, what we see is many agencies with funding create solutions in this part of the world, but they don't look at the sustainability. When the funding stops, the project stops. And farmers have lost trust in all this because they get abandoned halfway through. Once we have the economic viability worked out, which is like supply-demand balancing or the flow patterns, then we can initially put the societal empowerment and environmental sustainability into back burner for a little while, and then look at what knowledge is required to make the behavior change, because finally it becomes how you do things differently. It boils down to what actions you take as a community. The community thing is very strong. So we can look at what knowledge is required, how to source it, how to convert it to actionable, how to deliver it as a way to user empowerment, then how we monitor and generate the market intelligence and establish economic sustainability. Once we do that, then we say, look, okay, if we do that, what are the societal impacts? How do we balance? What are the policies, procedures required? And we enforce that onto the system. And then we looked at the environment. What are the effects on the environment? Are we putting back whatever we take? What are the measurements? And then bring in additional things like already we are looking at carbon sequestration by changing the way they grow. So we can bring that also into the same framework. Then we have a system where you can look at these SDGs while achieving the triple bottom line. So this is a quick overview of the systems thinking. And at this point, I will invite Dr. Javadi, who will show how we have extended this in Africa to mitigate hidden hunger, but also after that to show the generality of this approach. Dr. Ashini Wesumperuma will show how we have applied this in a completely different area of industrial lighting to achieve sustainable development goals, community and climate change. So over to you, Bahman.
Thank you, Athula. That was great. I think ending with the framework. So I think you listen to the background and now you know that how we apply the smart computing to the basically the SDG. So what I want to talk about is another basically example, and this is specifically done in many parts of the Africa. So the problem is we call it the hidden hunger, means that you eat enough calorie, but you don't get enough nutrition. So very simple example. So this is these two dishes, they have the same calorie, but obviously very different nutrition. And the problem is, especially for the kids, as you can see again, almost 30% or more than 30% of the kids in different parts of Africa, they don't grow enough because they don't get enough nutrient and they are shorter than they should be. And of course, this has the long-term impact on their health for the pregnant women and other disadvantaged part of the the community has an impact. So what we came up for the solution is, we know that those people with this hidden hunger problem, majority of them are farmers, right? And they don't have that much of the food affordability, because if they can afford the food, you can tell them what food they buy and they eat. But this is not the case for them. They grow their own food and they eat that. So what we come up with as a solution here is that we provide a mobile-based system for them, that we tell them what crops to grow to mitigate those hidden hunger. So for doing that, we need to know the location and the crops, basically information, and we need to know what food basically they're eating, right? So, and obviously we can't just get too much of the detail. We have the, a standard 16 type food that they have. So we understand what is the food that they're eating, where they're living, and what crops they're growing, and then we can give them a suggestion of the recommendation crops that they grow and they can eat. So basically what we're doing here, we diversify their food. There are parts of Africa, they eat, maize all 6 months long, right? So that diversification improved their hidden hunger. So this project, we did a 2-phase, and as you can imagine, it stopped before basically the year of the COVID. So it was 2 phases. The first phase, which was 2016 to 2018, was looking at the household and look at the food diversification. And we tell them what food they grow: potato, strawberry, maize, and other things. In the second phase, we look at that social empowerment and looking at a social network for the farmer, similar to the Facebook and X and other things that you guys use. We create a social network for them so they can do the community level and user connectivity that they can share their crops, they can share the food, and share the knowledge between them. So this again was an app which we call it the Ostavi. So Ostavi in Swahili means well-being, right? So that's the name of the app. So it has a similar knowledge base as Athula mentioned, but of course it's a different configuration that we did for this project. And again, the same thing. So we had the food survey, and then we had a recommendation crop, means that when you do the food survey, it gives you the recommendation of what types of crops are gonna mitigate the hidden hunger of that specific household. And it gives you the recommendation, and when you see which of them you can grow, and of course, then you can share it with the rest of that. So we did a lot of field tests. We traveled many times to the Africa. We worked with many teams, but one of the NGO that we're working with them, they did a field test in Balantir in Malawi, right? So they have a big community of the farmer, it's normally the female farmer. And this is a part of the survey that they did, that almost more than 70% of them, they want to grow on their food. So it means that the methodology that we came up was the right methodology. And 80% of those mother or a female farmer, they identified that this is a nutrition problem with their kids and their family. And more than 70% of them, they asked for more information on the healthy food. And we saw, the list is very, very long, and we had a lot of those information that we got, and we applied to our basically the project. Just at the end, this is an acknowledgement of many people and many teams that they work with different countries and NGO, and of course the Australian African network that supported this project. Given that we have a very limited time, I would like to ask Ashini to continue the presentation with her side of the story. Thank you, Ashini.
Thank you, Bahman. So good afternoon, everyone. So my name is Ashini Wesumperuma. So for this part of the presentation, the segment, I'm going to talk about different domains. Right? So it's about the digital transformation of the Australian commercial industry and how we effectively achieve climate action and sustainable communities, those two sustainable development goals. So this was a project funded by the Western Sydney University and the Aus Industries. So in Australia, there are government incentives for businesses to invest in energy-saving appliances. So in New South Wales, Energy Saving Scheme or ESS is this program. And then in Victoria, we have the WEET. So in this Australian commercial lighting industry, there are several stakeholders. So the lighting retailers, they sell lights and other products. And we have electricians who from different organizations go in and install lights, and wholesalers that sell these products as bulk, and accredited certificate providers who provide certificates where they see job evidence of jobs that are correctly done. And also we have manufacturers, government regulators, industry groups, and government teams. So how work happens? From the retailer organization, the marketing team would generally visit the customers, the organization, business organization on site, and then they will explain about the scheme and provide a quotation. And then if the customers are happy, then they can confirm the job, and the retailers will know the lighting electricians. So they will know their availability and they will schedule the installation. So on the day and on the time, the schedule, the installation will happen. While this is being done, the electrician will collect evidence for this job. And then the electrician will compile the evidence and submit it to a ACP. And the ACP will then, accredited certificate provider will then issue the certificate for that job. This certificate can be traded in the market like currency. So the energy providers must buy these certificates to set off the carbon emissions to meet their carbon emission targets. So in this industry, there are many challenges because this is dependent on a government scheme. So as we all know, rules and regulations change. So there is uncertainty about the stability of the business model, and then there's little trust among the stakeholders and about the products. And individually, what they had to offer was not satisfying the current business needs. So we came up with this solution, a platform to facilitate formation of entrusted circles along the value chain. Entrusted circles are a group of people who regularly meet to exchange products, services, or information. And then they have exchange mechanisms that have low transaction costs. So because of the trust they have in one another. So I'm going to explain about how this platform facilitated the entrusted circles, allowed us to build communities along this value chain. If you look at the users, when they visit the lighting retailers now, when they visit the customer site, they will collect user context information, like the electricity bill and the location, the scheme, and things like that. And then job context information, like the device that needs replacing, and also the and about the area, the perimeter of this lighting installation, and then also the looking at the job, the consultant would decide on information needs for this job. This information can be of two types. Quasi-static, that means it doesn't change as often, and this like the product, the models, the product names, the suppliers, things like that. And then current other information like the price of products and the price of certificates. So things like that in the information need. And then we have in the system prior knowledge. This knowledge is about the previous jobs and government audit trails, recommendations by the industry experts, things like that. In these knowledge bases, we can query ontological knowledge bases. We can query based on the parameters for this information need, and then we can get the context-specific actionable information. So this actionable information is at a granular level. So when you see the actionable information at a granular level, you don't need to process that as much. So you can take action. So the stakeholders with this knowledge, now they can decide where, because it will pinpoint to the stakeholders that are already there in the trusted circles. So they can go with them, or they can go to the marketplace and find new partners. So in either way, when this happens, when the job is complete, it will create a dynamic content. And this dynamic content will be useful for in future, right? So this will get fed into the system. It will get aggregated, and then it will be stored in the as prior knowledge. So with this system, as you can see, we achieved, we were able to address two sustainable development goals, climate action and sustainable cities, because we can see energy savings we can achieve by installing or improving or replacing energy saving equipment. And then this platform will connect stakeholders of the commercial lighting upgrades, and it will facilitate better collaboration amongst the stakeholders, and trust issues are minimized because the formation of the entrusted circles, and we are using social computing mechanisms here. So the stakeholders of this platform are now empowered to make the right decision at the right time with the right information. So that's it about this case study. So thank you very much for listening to the presentations. So what we want to say in conclusion is that so it's when you look at the world, the problems that we have, it's difficult to solve these at as a segment. So like at an activity level. So we need to think beyond that. We need to think at a process, the system level, to bring in the value to the stakeholders of these systems. So with that I would open these for questions. Yeah. Thank you.
All the online asking questions, maybe to chat.
I'll just check with Luke, who's monitoring our online chat, if there's been any questions come through. Thank you so much to our speakers.
No questions, Bar. I did have one. Do you have any data on how much maybe you've saved in food loss?
I think
Hang on, I'll just bring you the mic.
it's very hard to measure because it's all over. It's not a controlled experiment to get that. But we have anecdotal data, and we have done some impact studies for the university, but which says that we take the usage patterns as a proxy, and we monitor how these apps get used, and we see the peaks when there are economic crisis, which is very interesting. And all that, recently we compiled a report for the university to look at the impact these systems are creating. But some of the data will take years to gather, but there are enough indications and more interest coming to deploy these ecosystems now.
Thank you. Do keep us updated on those future reports. Happy to share those. I think we've got a question here in the room. If anyone would like to ask, just raise your hand.
Thank you so much for the interesting talk. One of the questions that I have is that, as I see in most of these systems that you introduced, human is part of the cycle. And you need human to enter data, you need human to collect the data that you need. And this is a challenging part as far as I know, because how do you incentivize human to contribute to these systems? How you are making sure that the data you collect is complete and things like that. I want to see what approaches you follow to do these kinds of human interaction with the system, because the IT part is kind of stable, but human is varying a lot, is a dynamic part of the system.
Thank you very much for that question. This is a wonderful question that you asked, because from our early work, now we actually offer a subject in our university for the undergraduates called social computing. And basically how it is different from enterprise systems is person is part of the system. So we send the message to the farmers and we get the response back. A simple answer to that, how do you empower, is GPS. When there was maps or in the equivalent is printed material leaflets given to the farmers, yes, they would have read it, or they would have not used it. They would have used it for something else, even to light a fire. But take the GPS, because it's actionable, they take the action. And immediately they get the next action. And it helped them to achieve the goal of going from A to B. Then what happens, because it's easy, when thousands are going, they can monitor how fast every vehicle is going and create a traffic map. Now, when you're in a junction, it says, go this way. This is the fastest route, but this is the shortest route, because that's that intelligence, which we now say market intelligence. So the key is how we deliver the information in a way the person is empowered. And empowerment means we give choices to the user to achieve the goals meaningful to them. So one of the early PhD projects was designing mobile applications for empowerment, where we look at lots of psychological theories, what motivates, the motivation factors, and extensive research was done, and a PhD was done. Actually, that PhD happened at Macquarie, not at our university, but in collaboration with this project. And that gave us a lot of insights how we can deliver the information to empower the users. Otherwise, those systems fail. And even we have gone further, that empowerment, and again with that needs to come the trust. And again, I didn't have time, but we have published how through the information flows, we build the trust as well. And once they start to own it, they will drive it. But there is that critical period which we really need to do it. And we need to think very differently. We need to bring things like design thinking, empathy, all that into design. If we just think as IT, I guarantee it's a failure.
Can I add something?
Yes.
Sorry, just quickly. So yeah, I think what we call the participant burden is the clear problem for many technology, right? Because you say, you need to do this, and then I do that one for you. And always when the participant burden is increased, then the engagement decrease. So that's very common. As Athula mentioned, it problem to problem, case to case, and a context to context is very different. Like, for example, the African project that I explained, when we started the first project, which was the household level, and we had the test with the farmers, and we asked them to do the step. At the beginning, they were a little bit confused. They didn't know what to expect. Why is that? But then when the second project started and we went to the community level, that's where we start understanding that how the system works. So in Central Africa and South Africa, there are the tribes and a community level farmer. They meet every week very regularly. They're all of them. They come, not even one miss, right? And when they decide for something that they want to do, then everyone's doing the following that. So we understand that those community are the very important if you want to start working that. So we work with those community. They have leaders, they have executives, they have all those hierarchy that we have in their farmer community. So that's where we start working with them, and then we try to connect them together. That what is the benefit, and when those you convince those manager and the leader that this is best, then everyone follows. So it really depends by the case that where you want to, basically what you want to do exactly. Yeah. Thank you.
I do have a question from Alf from our Hawkesbury Institute for the Environment. Approximately how many users have installed these apps at peak?
In Sri Lanka at peak, we were reaching closer to 5,000. And at the moment, we haven't sort of greatly promoted, but we have over 2,000 plus users active in these systems.
Thank you. I think we've got another question in the room.
Hello, sir. I am Parth Sarthi Pandya. I am assistant professor in Junagadh Agriculture University, Gujarat, India, and I am working on remote sensing and soil and water conservation. So regarding what you said, that irrigation, canal command, and the crop area and crop acreage estimation, have you tried to link or cross-check the data entered by farmers through secondary source, right? Remote sensing, and we are also working on developing some applications to estimate quicker the crop yield and what are the situation and moisture content, this kind of things. So are you planning to do in future? Or?
Yes, we know it needs to be done, but we couldn't do it within the resources we had. But certainly, this is where it's a collaboration. Again, I think what happened with that project was, again, it was funded by the World Bank. We had the project funding, but then they changed their priorities and it didn't go to the extent we like to have. And that is one reason we now use a very different approach. We use only the project funding only as a seed to get started, but now we have these sustainable models with a startup. And we go for a startup model because otherwise every project has a start and an end, and when the funding finishes, it dies. So we don't want that to happen. And as I said at the beginning, my goal is to have all this going till I die. But yes, we are very open for collaboration. In fact, this project is done in Gujarat with Anand Agriculture. We had their teams here, and there's 3 more coming in October. I think last week or so, I ran a workshop here for 60 undergraduates from Indian universities on digital agriculture. So we have lots of collaboration, but the way to go it is create that community knowledge, community collaborate, and we are very open for that.
Thank you. If you have any more online questions, let us know. We are interested in building a mailing list for anyone who'd like to be kept updated about future thought leadership events. So you can leave your email address in the chat or with Luke or myself, as well as if you would like to sort of connect with the academics who spoke today, just pass on your details. I'm sure they'll be happy to collaborate. Thank you so much for coming, everybody, and thank you to our speakers today.